Welcome to the trigonometric ratios lesson on finding angles. So trigonometric is the long fancy word. And a lot of other teachers will just say trig ratios. Okay, so we've seen these before. So we've always tried to find the missing side. But today I'm going to give you a scenario where if you have a couple of sides, can you find the missing angle and so forth. But just as a quick review, let's kind of look at what we've covered so far with this, just with all things trigonometry. So I've added this triangle here. I'm just kind of putting this at the top of the notes here. So what we've covered so far in trigonometry so far is we started off in the first cycle just being able to label the sides. So when you see a right angle triangle, so you have a right angle, have a right angle here, so you know you're dealing with a right angle triangle. You know that you can use Pythagoras, you can use Sohcahtoa, and so forth. But in the first cycle, all we did was we had to stand at an important place and then label the sides opposite, adjacent, hypotenuse. So again, analyze this right angle triangle, decide where you're going to stand, and again, if it helps you, draw your little happy face. Okay, so you're standing here, you're looking into the triangle here. Okay, so from there, you need to label the sides. So if you're looking into the triangle here, you're looking right across to the other side, that's opposite to you. Okay, so you can write opposite, you can write O, I guess, if you want. All right, so from there, if you're again standing at that corner, 32 degrees, that's the important angle, that's the one you know. I know you know the 90 degrees, but don't stand there. So 32 degrees, that's the opposite side. The hypotenuse is always the longest side, it's always across from the right angle here. Okay, so let's write in hypotenuse. And then that leaves us the last side, adjacent. Okay, so adjacent means beside you, so this side here is beside you, so is this side, the hypotenuse, but the hypotenuse is always the longest side, so that leaves the other side that's beside you is the adjacent side. The one across is the opposite. So again, this first step here is key to getting the answers correctly, so if you can't label these, you need to practice them. All right, so from here, then in the next cycle, we moved into being introduced to the primary trigonometric ratios, so the trig ratios. So we had sine, cosine, adjacent, hypotenuse. These are the formulas. I'll always provide them to you. And then here's the little memory aid here. Sohcahtoa. So again, if you were wondering why everyone kept saying that, it helps you kind of get to the formula really quickly. So sine is opposite over hypotenuse, O over H. Cosine is adjacent hypotenuse, A over H. And tangent is opposite over adjacent. Okay. Again, so if you feel like you are comfortable with this stuff, you know how to find the sides and so forth, feel free to just kind of move ahead in the video and get to the new stuff. All right, but if you need the review, just hang in here and just kind of watch this. So I grabbed the example that we had above here where we labeled the sides, and now we're going to use that same example and actually go through and calculate out the missing side. So this is a right angle triangle, so some of you may have thought, oh, I can use Pythagoras, but Pythagoras, you need a couple sides in order to find the missing side. In this case here, we only have the one side. The side's missing. We know nothing about this side. But the other clue that we do have is the angle. So whenever you have those clues, you can go, okay, I can't use Pythagoras, but I can use Sohcahtoa. Because again, Sohcahtoa only works with right angle triangles. Okay, so go through the steps of, again, labeling the sides. Okay, so that's the opposite, that's the adjacent, and you know, you don't need to label the hypotenuse, but you can. Okay, so from here you have, right, I'll write Sohcahtoa out again. So some of you, it was helpful to do this, so write these out. And then you go through and decide, okay, in order to find the missing side, we need to figure out which formula we need to use. So I always said, okay, go through, see how the adjacent, you know the adjacent side. So let's give the A's all a check here. So we know we have the adjacent, we have the adjacent. Okay, then from there, we need to find the opposite. So that's another important side. So we're going to check all of the O's. Okay, and then if you look at the hypotenuse, we don't have it, but it's not something we have to find, so we're not going to give that one a check mark. So then when you go back to the formulas here, you'll notice, oh, okay, both of these, opposite and adjacent, we have those, so that's why tangent is the one that we need to use here, where we can't use cosine, we can't use sine because we don't have enough information. We need to have hypotenuse for those. Okay, so we're going to use tangent here. Okay, so write out the formula here. So tangent theta is opposite over adjacent. Oops, adjacent. Okay, scroll up here. Okay, so again, this theta here is the angle. Okay, and this is the opposite side, that's the adjacent side, and tangent is the trig function that you're going to use in order to help you calculate out the missing side. So let's just go through and fill everything in. So we know tangent, we know the angle is 32 degrees, and the opposite we don't know it, but we're going to call it x, and the adjacent is 15 centimeters. Okay, so from there, we need to solve for x. Okay, so again, we were practicing just our solving skills from last year and trying to get really good at them because we're going to use them a lot this year. So hopefully you're looking at this equation here, and you have to get x by itself. So you're looking at and going, how can I get rid of the 15? Well, I'm going to move it to the other side here. Okay. And right now it's divided, so I'm going to multiply it over here. Okay, so I need to take 15, multiply it by tangent 30, and that's how I'm going to get my x value, which is the missing side. So again, get out your calculator and make sure it's in degree mode. I'm just going to use one that's online here. Okay, so if you just want to Google the following, so you have Desmos scientific calculator. In the past we've used just, if you type in Desmos, it goes to the graphing site. Here if you type in scientific calculator, it will go to kind of a nice calculator. Well, it's an alright calculator. If you want to use your phone, you can do that. If you have your own scientific calculator, that's good, but if not, this was one that works. Okay, so we needed to type in, it was 15 tangent 32 degrees. Okay, so I'll just click back and show you here. So 15 tangent 32 degrees. Okay, so in here, so just type in 15. Oh, actually, so if you are not using this, just make sure your calculator is in degree mode. Okay, so if you wanted to test to see if it's in degree mode, for example, if I type in sine 15, you should be getting 0.2588, etc. on your calculator. Okay, if you are in degree mode, in radians or gradients mode, you'll get some other numbers here. So just make sure that when you actually type in sine 15 on your calculator, you get 0.2588. That's how you know you're in degree mode. So in here, if you're just fiddling with this, see how it's on degrees, then it's good. So if I click it here, it'll change to radians, and then the number changes. So you want to make sure that you see degree, and then you're in the right mode. Okay, so we have sine, cosine, tangent here that we can use. So what we want here, okay, it was 15 tangent 32. So 15 times tangent 32, okay, and there's our number, 9.37. So we're going to write that in here. So x equals 9.37, and the units will be centimeters. Okay, I don't know what to round to here, so we'll just leave it at 9.37. Okay, so that's what we've done in the past. You had to label the sides, you were given a side and an angle, and then you had to find the missing side. Okay, so today what we're going to do is, so if you just want to jump to one down here, you're going to have a couple sides, and then I'm going to ask you, say, to find angle A. And so you have to do that using the fact that you have the two sides. Okay, so again, Pythagoras, if you were going to use it, that would help you find the missing side here, but that's not what we need to find. We need to find the missing angle. Okay, so that's what we're going to do today. Okay, so now here's the new stuff. What we've always, but still talking about the old stuff, what we've always done here in the past is that we've always set up an equation and one of the sides was always missing. So we always had the variable over on this side. We always knew the angle. Okay, so what's happening with today's lesson is that we're going to have the angle missing. So right here, if you take a look, sine A equals 1 over 2. We need to figure out what this A value is going to be. So again, we are still going to be using sine, cosine, and tangent in a way, but we need to use, it's just like when we're solving equations, like the opposite of adding, subtracting. Okay, so if we're throwing something over, do the opposite. If the opposite of multiplying is dividing, the opposite of squaring is square rooting. So the opposite of these sine, cosine, and tangent operations is going to be the inverse sine, the inverse cosine, the inverse tangent. Okay, so we need to figure out how to do this on our calculator. So just again, make sure that your calculator is in degree mode. Okay, so again, like if you wanted to check if you are doing it right, so clear that out of there. And again, so let's just say sine 50. You should get 0.2588. Just hit enter and it looks like it stores the previous calculation for me. All right, so now that you have tried sine 15 as 0.2588, you know that you're in degree mode. So what I want you to do now is I want you to look through your calculator. Look at the buttons where sine, cosine, and tangent are on your, if you have an actual scientific calculator, and you'll see just above it, not the buttons above, but just above it, there's some writing above, and you'll notice it's a different color. So you're going to have to hit shift or second the button, and then click on sine, for example. So for example, with this calculator here that I'm using with Desmos, I'm going to go to, let's see here, what does ABC do? Okay, goes to letters. Go to the function, F-U-N-C, and then you'll see these ones where it has a sine -1, sine, cosine -1, tangent -1. So you should see something like that on your scientific calculator as well, just above the sine. So if you have your sine button, usually it's just above, and then it has the sine -1. So this is the opposite operation. You can think of it that way of these corresponding ratio trig functions here. So just let's do a test run here. For you to have, if you were to take the inverse sine, okay, so let's say, I don't know, let's do 0.5. Okay, so if you're doing the inverse sine, you should be getting 30 on your calculator. So please try that right now. So if you have a scientific calculator, shift inverse sine, or sine, which gives you this sine -1, and then 0.5, you should be getting 30. Okay, and that's 30 degrees. Okay, if you're having issues, just email me and I'll try to help you with this. Okay. All right, so now that we have figured out how to use the calculator, let's go back to our notes here. Oops. Okay, so if you are taking a look here at our first example here, so I want you to solve these for the angle. So basically, you need to find the angle here. If you look at this first question here, cosine x equals 0.237. What it is that it's kind of like the number that you used to have here, 1 over 2, 3 over 4, 4 over 5. So basically that number there is that ratio that you used to have to find the missing side for, and so forth. So now, given this here, can you find the x value? Okay, so if you were to write this out and show your work, this is what you need to do here. So I want you to think of it as you're trying to solve for x, and right now we have cosine stuck to it. So how do we remove this? Okay, so it's just like any time you've had to solve for x. Like if I do an example here. So if we have to solve for x, we're looking at, okay, we have a 1 and a 2 stuck to the x. I need to move the 1 first. So I'm going to move that. So the opposite of adding is subtracting. So when I throw it over here, it becomes subtract. Okay, so now I need to get rid of the 2 on the x. So the opposite of, okay, so right now it's multiplied on. So if I'm going to throw it over here, the opposite of multiplying is dividing. So I'm going to divide it over, and my final answer is 2. Okay, so it's still kind of like it's like the opposite operation, the inverse operation. So what you're going to be doing here with the cosine x, back in A here, is the same thing. So you could think of it like moving the cosine to the other side of the equal sign. So if you were to do that, so I'm going to move just the cosine over here. If I do that, so the x stays behind. Okay, so just like when you move something over on these ones here, you always change it to the opposite operation. So if it was added, you would subtract it. If it was multiplied, you would divide it. So in this case here, the cosine x becomes, when you toss it over, it becomes the opposite inverse operation. So it's the inverse cosine of this number that's already sitting there. Okay, and that's how you're going to solve for x. So you're going to take the inverse cosine of 0.237. So let's do that on our calculator now. Okay, so we need to take the inverse cosine. So let's go to here. Okay, and it was 0.237. Okay, and you'll get an angle of 76.29. The other screen, so 76.29. Okay, and you want to round to the nearest degree. So you'll get 76 degrees, and there's your answer. So let's try the next one here. So we have tangent. So again, we're going to solve for b, the angle there. So we're going to move the tangent over here. Okay, so when we do that, it becomes inverse tangent. Okay, and then we're going to take our calculator and calculate that. So inverse tangent, 4/8, is 26.5650. And again, so what you're doing is you need to round to the nearest degree, so we need to keep this. You're looking at this number here, and it's 5 or greater, so we're going to round up to 27 degrees. Okay, and let's move to the next one. So we're going to move the sine over to the other side, so it becomes inverse sine, 10/13. Okay, here's our calculator, so inverse sine, 10 divided by 13. 6, okay, and so we need to round to the nearest degrees, so nearest whole number, so we're going to keep this. We're going to look here though to see if we're going to round up. Nope, see how it's not 5 or greater, so we're going to keep it at 50. We dump everything else off. Okay, so I just wanted to add this little note here, just to remind you. As you're going through, just keep in mind of the opposite operations here, so or inverse operations. So for example, like you know that the opposite of adding, you're going to subtract it. Opposite of multiplying, you're going to divide it. Okay. If you had squared, if something squared, the opposite would have been to square root it. And then now that you're in grade 10, you know the square root of plus or minus. Okay. And so now, what are the things that you've learned today? So if you have sine, the opposite of sine, inverse operation is the inverse sine, okay? And you have cosine, the opposite is inverse cosine. And tangent, the opposite operation is inverse tangent, okay? Okay, so let's move on to the next example here. Now, if I give you a picture, can you go through and do the same thing? Can you build the equation that you need and find the missing angle? Okay, so in these questions here, I specify what angle to find. Okay, so for A here, it says to find angle S. So I know that when you were trying to label the sides in the past, there would be a number somewhere in here or here, and you would stand there and label the sides. But here you have to pay attention to this clue. Okay, stand or find angle S. That's where you need to stand. Okay, so just draw a little happy face here. Oops. Okay, and look in. This is the opposite side. That's the hypotenuse. This is the adjacent side. Okay, so if we're doing our Sohcahtoa, okay, you could do a little checklist here. Okay, so what do we have? We have the adjacent. We have the adjacent. Okay, so check both the A's. We have the opposite. Okay, we don't have the hypotenuse. Okay, so in order to find angle S, which formula should we use? We need to use the tangent formula. Okay, so let's write that in. Tangent theta equals opposite over adjacent. Okay, so let's fill it in. Just remember theta here, the theta here is the angle. Okay, so tangent, well, the angle is S that we have to find. We don't know it, but we know the opposite and we know the adjacent. Okay, so it's really important that you label the sides properly, and then it's important that you put the numbers in where they're supposed to go in the formula. Okay, so from here, this is just like what we did above. We started with these equations and then we just had to solve for the variable. Okay, so let's put the tangent over, okay, because we need to solve for S. We need S by itself, so the opposite operation of tangent is inverse tangent. Okay, so again, go to your calculator and calculate that out. Make sure you're in degree mode, and you should get the angle is 75.749, etc. Right, and you need to round that to a whole number. So again, if you need practice with rounding, we need a whole number, so we need to retain the 75 part here. So I'm going to look at the decimal and the first number after the decimal, which is the 7 here, and see how it's greater than 5, so 5 or greater. What you're going to do is you're going to end up rounding this number up to 76. Okay, and that's the missing angle that you needed to find. Okay, angle S. All right, let's go to B. Okay, so if you feel like, oh, I got this, you can go ahead and work on the next question. If you want to go down here, this example here, you need to solve all the solve the triangles. That's the quick description of find all the sides that are missing, find all the angles that are missing in order to get full marks. Okay, so just kind of go through here, throw everything at it, throw Pythagoras if you want, Sohcahtoa, the inverse sine, cosine, and tangent functions now. Okay, but otherwise, if you need more practice, let's keep going through here. Okay, so that's with this video. Feel free to just kind of jump to wherever you need to go in the video. All right, so for this next one here, I purposely made the instructions slightly different. the A was find the angle S. B is find, it's like this, what's the symbol? It's an angle, right? KDU. So what angle is that? Okay, it's saying all the letters of the triangle. So if I ever say this, find angle KDU, it just means start with K, go to D, go to U. So that shape there, where is the angle? Right here. Okay, so it's like the angle is sandwiched between K and U, right? So KDU. So if you were to trace that out, that's the angle that it just made. So we need to find essentially angle D. All right, so happy face there. Look in, opposite side. Hypotenuse is always across from the right angle, and this is the adjacent. Okay, so Sohcahtoa. Again, you don't always have to do this. You can hopefully just kind of look at and go, all right, I have the opposite side. I have the hypotenuse. So I have the opposite hypotenuse. What formula is that one? Oh, yeah, that's a sine. Okay, but if the checklist thing works for you, use it. Okay, so I'm looking in here and I'm like, okay, I've got the hypotenuse, and I don't have adjacent, but I do have the opposite and opposite. Okay, so the one I need to use here is the sine equation. Okay, so that one is opposite over hypotenuse. Okay, so again, I found that some of you were good at labeling the sides, but and you were able to actually find the right trig function to use, but then you used the wrong formula. So just take a second and make sure you're writing down the right formula. Okay, have them listed somewhere on the side of your note. Okay, so let's fill this in. So again, it's angle KDU, but really it's angle D here, so I can just even write angle D if you want. Okay, and opposite is 5 over hypotenuse, which is 13, and then just go through the steps and solve. Okay, so you need to find the angle. So every time you have to find an angle, it's always the inverse trig function. Okay, so if you're trying to find a missing side and you're doing the inverse trig function, it's incorrect. Okay, and here we go. We got 22.61986, blah, 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 blah. Okay, and then I want you to round. So again, you need to keep these two. Look at this one, okay, and decide, do I round it up? Do I keep it the same? Okay, so since it's where I'm pointing the arrow at, it's greater than 5. Okay, so that means you need to round up the 22 to 23 degrees, and then we dump everything else after the decimal. All right, and the next one. So here, find, so you'll just see the angle F, like sometimes you'll see the instructions like that. Sometimes you'll see the instructions, the word angle S, or like this is a good way to label angles, KDU, and it's really clear which angle you're talking about. Okay, so be able to, handle all three of these different types of instruction. Okay, so angle F, so that's where you're standing. Label the sides correctly. Hopefully, like, you get to hear and you're like, oh, opposite and adjacent. That's going to be tangent, okay? But again, if you're not quite there, yeah, list them all off. And then check off the ones that you need. So here, I have adjacent, I have opposite. Okay, so I need to use TOA, tangent. Okay, so let's fill it in. So in this case, you remember it was angle F. So the theta turns to angle F. And opposite is 3, adjacent is 4. All right, and let's boot the tangent out of there. So it becomes the inverse tangent when it goes to the other side of 3 over 4. So again, inverse tangent. This calculates out to 36.86989, etc. Okay, and so again, you want to keep these. You're looking at this number here. Okay, it's greater than 5, so round it up to 37. And don't forget the degree symbol. Okay, so it's like your units, like centimeters and stuff like that. So just do that to get full marks. Okay, let's move on to the last example here. So hopefully you're confident with finding the inverse tangent, just calculating that out. If I give you a triangle, setting up the equation, filling it in, and then finding the inverse tangent, finding the angle. So now we move to this type of question here. So sometimes you'll be given one where it just says, okay, solve the triangle. Okay, so if you ever see that, I'm not going to always have, okay, this means finding all the things that are missing. Okay, so just know that whenever you see solve the triangle, it means go and find every single side that's missing, find every single angle that's missing. Okay, there's lots of different ways to approach this. It depends on where you want to stand in the triangle, what you want to find first, and you can throw a lot of things at it. You know it's a right angle triangle, so you have lots of tools under your belt now. So you have the Pythagoras. So let's kind of list them off here. Okay, so tools that you have now. Okay, so you have Pythagoras. Okay, so Pythagorean Theorem. Okay, that's that a squared plus b squared equals c squared. That can help you, right? So again, you just need two sides and you can find the third side with that one. You also know Sohcahtoa. Okay. Okay, so if you have those, and so basically if you have two sides, you can find the third side for Pythagoras. For Sohcahtoa, if you have a side and an angle, okay, you can find another side. Okay, so again, Pythagoras, here are two sides. You can find the third side. Okay, so remember, this is for right triangles. So you have to have a 90-degree angle in the triangle. Okay, all right, so Pythagoras, so you have a couple sides, you can find the third side. Sohcahtoa, so that's sine, cosine, tangent. If you have a side and an angle, you can find another side. And then what you just learned today was the inverse. Inverse trig functions. Okay, so inverse sine, cosine, and tangent. Okay, so these ones here. So with those ones there, if you have a couple of the sides, you can find the angles. Okay. Another tool that you know is that if you know that if angles in a triangle add up to 180, okay, that can also help you with these as well. Okay, so throw whatever tool you want at this question here, and feel free to, like I'm going to have one solution right now, but you can do it a different way. But we should all be getting the same answers for the angles and all the sides and so forth. Okay. One more thing that I want to point out is as you go through this, don't round if you find, for example, this side here using Pythagoras, don't round it. Okay. Carry a few digits. That's just a key thing to do when you're doing any math or science questions or any courses like that. So you always want to carry a few digits And then when you're going to present your answer at the end, I want you to finally round up to whatever it says. So like in this example here, it says round to the nearest degree for the angles, and for the sides, round to 1 decimal place. So just make sure, carry a few digits on all the results that you get, because sometimes if you find like this missing side, you might need it to use it to find this angle. And if you round this one up, it can end up affecting the results of this one. So you always want to carry a few digits so that you can get the best results that you can, and then in the end you can round up to whatever the question is asking you to do. Okay, so again, just one more rule of thumb here: don't round values until the end. Okay. So now that we have analyzed all the tools that we have in our tool belt, let's go through and try this question. So again, the way you do it might be different from the way I do it, might be different from the way another classmate does it. So in the end, we should all be getting the same values. Okay. All right, so again, we need to solve the triangle. So that means we have angle B is missing, angle A is missing, angle A to C here is missing. So we have 1, 2, 3 things to find. We do know this angle already. A little square means it's 90 degrees. So we're good to go there. How about I'm going to start with using Pythagoras. I'm going to try to find the last side here. Because if I have two sides in a right angle triangle, I can use Pythagoras to find the third side. So I'm going to start off with labeling the sides here. Okay, so again, remember we practiced if you have the corner vertex C, this is baby C then. Okay, A is, capital A is always across from little a here, side little a, and angle corner vertex B, little b is here. Okay. In the end, it doesn't matter. You can label it what you want. So let's use Pythagoras now. Okay, so a squared. So I don't know. Let's actually label. I'm going to find side B. Okay. So I'm going to use Pythagoras. So A was 31. B we don't know. We'll leave it as B. And C is 42. Okay, so squaring them all. All right, so I'm just going to calculate those out. All right, this is 961 plus B squared. And oops, this one is 1,764. Okay, so we're going to keep going here and we're going to solve this equation. So again, this is something we've already done before, so just a good way to refresh. All right, so we're going to put that, we're trying to get B by itself, so we're going to move anything added or subtracted. Okay, using SAM-DEB to solve our way to the variable. Okay, and this works out to 803. All right, and the opposite of squaring is, we're going to put that square over. We're going to square root. Okay, so I'm just trying to get you guys in the habit of writing plus or minus square root. Okay, so if we take the square root of that, we will get plus or minus 28.3375, okay, etc. So I know some of you are looking at this and going, well, why didn't I leave it as the square root of 803? Well, I know that eventually the side I have to round it. So since I know that the decimal answer is acceptable, I'm just changing it to decimal. Okay, but looking at the plus or minus answers here, hopefully you can see that a negative side length of negative 28 doesn't make sense. So we're going to reject that, and then we're only going to take the positive 28.3. Okay, and again, I'm carrying a few digits here. It's important. I want you to do this. In the end, you can round it up, but for now, I might use this side B again in another calculation, so I don't want to round it up yet. Okay, so we found one of the three things. So we found side B. So now we're going to go back up here. So we can even, if it's helpful, it can be helpful. So sometimes just write what you find anytime in math onto the diagram, just to remind yourself that, okay, I found that side already. And it might help you solve other things as well. Okay, so from here, I am looking at, I still need to find the angle A and angle B. Okay, so angle A and angle B. So you can use so like again, if you're looking through your tools here, the tool that finds angles is this inverse, this new concept that we learned today, finding the angles, use the inverse trig functions, okay? This one here where angles add up in a triangle add up to 180, well, we only have one angle right now, so we can't use that one yet. So let's use the inverse. Again, so we need a couple sides to find an angle. So see how we have three sides now? This one here, because it is a decimal, we did round it up a little bit. It's not exact, so I want to go through and use the 31 and the 42 because those are exact. You want to use those in order to find the angles because that way you get a more accurate answer. Okay. All right. So I'm gonna find. Doesn't matter which one you find first. I'm gonna find angle A first. Okay. Or no, yeah, angle A. So I'm gonna do the usual stand at angle A. Okay. Look in. That's my opposite side. That's my hypotenuse. Okay, and this is my adjacent side. Okay, and that's if I stand at angle A. So if you guys are finding angle B first, you're going to stand at angle B, and then the opposite and adjacent will be in different spots. So just keep that in mind. Okay, so lots of different ways to solve this, but I'm going to say stand at A first. Okay, so that means I'm going to find angle A down here. So I'm finding angle A. Okay, so for me to go about doing that, I want to use those two sides that are the exact values. Okay, so I know I have an adjacent side, so I could really use any trig function, sine, cosine, or tangent, but I want to use these exact ones to get a more accurate result. So I'm going to use opposite hypotenuse. Okay, so again, if you're thinking about which function has opposite hypotenuse. Okay, write out Sohcahtoa. So the ones that have opposite hypotenuse, that's sine. Okay, so we want the sine function here. Let's just write it out. And yeah, let's fill it in. Okay, so the theta, that's angle A. The opposite side was 31, and the hypotenuse was 42. Okay, so we're going to double check those. Standing at A, opposite is 31, hypotenuse is 42. All right, so let's go through and solve this. So again, this is the new concept that we learned today. So when we get in a scenario like this where we need to find the missing angle, you're going to set up the trig function. Okay, and then we need to solve for A. So you're going to set up the trig function. You need to solve for A here, so you need to boot the sign out of there and move the sign over here. And so that way I isolate A. And then when I move the sign, though, it becomes the inverse, the opposite operation, inverse sign. Okay, so again, make sure your calculator is in degree mode and take the inverse sign of 31 over 42. And you get the angle will be 47, 5, 6, 9, 4, 1. Okay, and again, I know that I have to round the angle up to the nearest degree eventually, but right now I'm just going to carry a few decimals because again, it's more accurate to do that. I might need to use angle A to find another result. Okay. All right, so let's see here, 47.5. Okay, so I'm going to put that right in here. 47.5. Okay, 6, etc. There it is. From there, now that leaves us with our last angle B to find. So again, I could use Sohcahtoa and the inverse sine in order to find the angle B here. So I could go through and put a little happy face here, rename the sides, and then use the inverse function here. But what you could do instead is that this last tool here, the angles in a triangle add up to 180. That's something you learned back in maybe elementary school. You can use that here. Okay, so cut down your work. So to find angle B, to find angle B. A mess here. Okay, angle B. Okay. All right, so what we're going to do here is we're going to use the angles in a triangle add up to 180. So we know that. So to find B here, let's call B equals what we're going to take 180. All right. We know this is a 90-degree angle. We know this angle that we found. Okay, so if we take those and subtract it from 180, we will get to our angle B. Okay, so here's an example where you need to not round up angle A because we're going to actually use that value now to calculate B. And if we carry lots of digits here, we can improve our accuracy at calculating the right number. Okay, so there's that number there. So let's subtract that. 180 minus 90 minus 47.56941, and carry more digits if you want. Okay. The rule of thumb here is, like, if you're wondering how many digits should you carry here, okay, it's go and look at and see what they want you to round to. So it says find the angles to the nearest degree. So you know that you need to round to whole numbers. So I know I carried 5 digits. That's a little excessive. Maybe if you carried 3, it should still be okay. But just, I don't know, rule of thumb, carry at least 4 extra digits if you can. Okay. All right, so when I subtract those, I end up with 42.43059 degrees. Okay. All right, so now we found so we can even write that in if you want. Okay, so we found all the things that we're missing. We found angle A, angle B, angle A, angle B, and side little b here, or side A to C. Okay, so we found the 3 things. So we have now solved the triangle. So you want to make a therefore statement here. Okay, and at this point here, you can round up the values. So the angles round up to the nearest whole number. So if you wanted to write them in now, so okay. I'm going to go here, and then the sides, we're just rounding up to 1 decimal place. Okay, so again, you need help with, I know a lot of you asked me to help you with the rounding here. So in this case here, we have to round up to 1 decimal place. So I need to keep this 3. So we're going to look at the next digit, which is also 3. And we're going to decide, okay, that one where the arrow is pointing, it's not 5 or greater, so we're not going to round up. Just going to keep the value the same, 28.3, and then I'm dumping the rest off, okay? Just double checking if there are units. Nope, no units, so you could just call it 28.3 units, okay? And then angle A here, so we're going to go through, we need to round to the nearest degree. So again, you need to, keep this part here, 47. You're going to look at this first number here that we're going to dump off. It is a 5, so that means you should round up. So angle A becomes 48 degrees, okay? And angle B here, again, round to the nearest whole number, so you need to keep that. Look at the first number here. Okay, it's a 4, so we're not going to round up. We're just going to keep it the same. 42 degrees. Okay, so it is key here, depending on, it doesn't matter which way you went about solving this, you have to get these exact values. So if you ended up with 43 for angle B, or you got like 49 or 50 for A, and you're like, oh, that's close enough. It's not. It means that you had a rounding error somewhere through here. So maybe you rounded up too early, maybe you made a calculation error. But usually when you're close like that, off by 1 or 2, it's usually a rounding error. So that means back here, when you calculated A, you rounded this up to 48, and then you calculated it up here. And then, so if you subtract 48, okay, so around does come out to 42, but sometimes it makes it go off by 1 or off by 0.5, or it causes an error in rounding, and you're going to find, again, people have done this and crashed things, blown things up because they weren't being accurate. So just, yeah, rule of thumb, carry some digits, extra digits, and then at the end, round it up. Okay, so now that we've rounded everything up, we can make a therefore statement here. Oops. Okay, so therefore, okay, because it said to solve the triangle, so therefore you can say side B, so side AC, or, you know, we call little b, is 28.3 units. Oops. Units long, and angle A is 48 degrees, and angle B is 42 degrees. Okay. All right, and yeah, so these are the typical questions that you'll see today for this new inverse trig function. So again, when you are trying to find sides, you just use sine, cosine, tangent. Okay, so usually you have a side and an angle, and you can find the other side. But if you do need to find the angle now, you need to use this inverse sine, inverse cosine, inverse tangent to find the angle. So generally you'll be given two sides. You have to find the angles. Okay, and you should be able to handle one of these where you throw everything at it. Okay, everything that you've learned so far in order to find all the different pieces that are missing. All right, so if you need, so to get extra practice here, here's some textbook questions here that you can work on. I'll also attach some worksheets. Again, make sure try some. Make sure you feel confident. Check your answers, please, because a lot of you aren't checking your answers and just thinking, oh, I got this. And then, so just make sure you're good to go. And then please try the checkpoint and submit it when you're ready. Okay, thank you.